Hi, welcome to Tammy the Tutor. We are in CC2 lesson 1.2.6 today. The first question is 110. It says Vu needs to add 3/8 and 5/6. He knows that he can rewrite each fraction as a portion of 48 because 6 and 8 are each factors of 48 in his multiplication table. Is there a smaller number that could work as a common denominator, he wonders? Where can you look in the multiplication table to see if 6 and 8 are each factors of a number less than 48? Okay, so as you're looking at this multiplication table they have for you, they have already circled the two 48s, and I want you to notice that this 48 is in the 8s column and in the number 6 row. And then this 48 is in the number 6 column and then the 8s row. So you just find the two numbers that they're talking about, which in this case is an 8 and a 6, because those are our denominators. And you find one of them here, and then you look at the opposite one here, okay? So definitely 48 could work as a common denominator, but when you are getting common denominators and adding and subtracting fractions, trust me, it is easier and cleaner and faster if you can go ahead and find the smallest number that they both divide into. Yes, they do both go into 48, and yes, it could work and you'll be fine. You'll just have a lot of reducing to do at the end, but it is worth your time and effort to learn how to find the smallest common denominator first. So they're saying, where can we look? What can we do? Well, obviously, if we're dealing with a 6 and an 8 as a denominator, you're still going to look in the columns and the rows of the 6 and the 8. Let's just see if there's anything else they have in common that happens to be smaller than 48. I'm going to look down here on the 6s, and I'm just thinking 6, 12, 18, 24, they're okay. Usually, within the first 4 or 5 numbers, you can find something that's common. So now I'm going to come down here and look in the 8s, 8, 16, 24, okay. I've already found it. That's actually the first number that they have in common. So that is the least common denominator. That is literally what that's called, and you'll see it just LCD in math. If you're ever wondering, what is this abbreviation for? It's the least common denominator. Okay. B, use the multiplication table on the lesson 126 resource page to find other numbers you could use as a common denominator to add. Okay, so this multiplication chart that we're looking at only goes to tens, and so we need to see if this other one, if this will take us to a different one. Okay, good. Okay, yeah, so this one goes all the way to 15s, so we should be able to find the next number. So we already know that, so the 24s, let's see here. Yeah, I can't write on this page. So let's just know that the 24 and the 48 have already been found. The next one they have in common. Let's just go down the list and look at the numbers. So go all the way to 48 because we know it's going to be past the 48. So 54, 60, 66, 72, 78, 84. Okay. So think about that. Now go to your 8s, go to the 48 and go past it. 56, no. 64, no, they didn't. Oh, 72, right there. They both had a 72. So right here for the 6, there's a 72. And for the 8, there's a 72. So there's the next one they both have in common. Okay, now that we've found out that another common denominator is a 72, I'm going to write that here. Up here, remember, we found the 24, so I'll go ahead and write that down for you. Then see, Vu's next problem is to, oh, hold on. I think we were we supposed to find this one? No, we weren't. Okay. His next problem is to add 5/4 and 7/10. Use the multiplication table to find the smallest number you could use as a common denominator. Now they're telling us it's called the lowest common denominator. After you find it, find the sum. Okay, so we are going to be adding 5/4 plus 7/10. Okay, so to find the common denominator between a 4 and a 10, here's a life hack for you. Sometimes I teach kids to write down their denominators and then to start listing the multiples, which is basically what you're doing with this chart in front of you, which is great, but you're not always going to have a chart in front of you. So this is something that you can always do on your own. But start with the bigger number first, trust me. Because as I'm going to start listing the multiples, I'm going to ask myself, well, I already know a 10 can go into every one of these. That's not the point. Just list the multiples of 10. You know a 10 divides into each of them. But as you list them, stop and ask yourself, does a 4 go into this? Because as soon as a 4 goes into it, then you have found the lowest number that they both divide into. For instance, okay, the first multiple of 10 is a 10. Well, a 4 doesn't divide into a 10, so I will try the second one, which is 20. Does a 4 go into 20? Yeah, it does. It goes in 5 times. So look how fast and easy it was to find that common denominator. Or yeah, you can use the chart. You can come up here but again, start with your bigger number first. Start with your 10 and go across until you can find a number that 4 goes into. There it is. There's another one. You could have, kept going. There's another one. But you want the lowest one possible, so it's a 20. Here we go. We are going to use our giant 1. 4 times what is 20? 10 times what is 20? 5 times 5 is 25. 7 times 2 is 14. 25 plus 14 is 39 20ths. You want to turn it into a mixed number, so 20 goes into 39 one whole time, and out of 20 there would be 19 left over. Okay. 114. For each part below, find a giant 1 that will multiply the fraction of the left side of the equation to create the equivalent fraction on the right side of the equation. Then complete any missing information. Okay, so they have the giant 1 set up for you already. Their giant 1 looks so much prettier than mine. So if you notice, they've always got a full fraction on either the left or the right hand side. Their full fraction is here. So you want to deal with the two numbers that they have across from each other. See, if you go down to the 6, you don't have a number to compare it to down here, but up here I've got the 5 and the 15. So that's where you're going to start. Ask yourself, 5 times what is 15? And that happens to be 3, so you know 3 goes on the bottom. And then 6 times 3 would be 18. Okay, let's go to B. This time the two numbers across from each other are on the bottom. So 3 times 2 is 6. Write a 2 up here. And what times 2 is 4? You have to think backwards on that one. Or you could have come up here and said, 6 divided by 2 is 3, so 4 divided by 2 is 2. It works either way. Okay, so we've got the 2 and the 16, so that would be 8 and 8. So what times 8 is 8? Well, that would be 1. 4 times what is 24? 6. What times 6 is 6? 1. Probably are feeling really good and confident about the giant 1 by now. 115. Okay, Fareed wants to add 1/4 plus 5/8. Add the fractions by using a giant 1 to create a common denominator. Okay, we've been doing that for a while, if you've been following along with me. Here's some giant 1s. And if you wanted to practice what I talked about with finding a common denominator, here they are. Start with the bigger number first. Start with the first. Oh, you know what? It only took the first one. We know an 8 divides into an 8. And guess what? A 4 also divides into an 8. So 8's our common denominator. Well, guess what? This one already was out of 8. So that one's not going to change. I didn't need to touch that one really. This is the one we are going to change. And this is going to be a 2. And then when we add the 2 and the 5, that equals 7/8. B says, how can factors help you find a common denominator? Well, it just helped us down here because we knew that 4 was a factor of 8. So we knew the moment we listed 8, we were like, oh, yep, 4 is also a factor of 8. So that didn't take us very long at all. Mario was visiting the carnival when he noticed a few number relationships. He made them into brain teasers for you. If 3/10 of the visitors were adults and there were 100 visitors, how many visitors were adults? Okay, it looks like a lot of words, right? But it's really a simple equation. Okay, so if 3/10 of the visitors, by now, I'm hoping you realize the word of in math always means multiply. If you're doing any kind of word problem and you see the word of, it will always mean to multiply. So it says 3/10 of the visitors. Well, also, guess what? It already told, yeah, it said there were actually 100 visitors. So 3/10 of the visitors, or the 100, you with me on that? Okay, so how many were adults? So 3/10 of them were adults. All we have to do is multiply 3/10 times 100. You can do that if it makes you feel better, and multiply straight across. And then when you divide this, it's going to be 30. Or another thing you could have done is 3/10 times 100. You could just simply cross multiply. 100 divided by 10 is 10. And then 3 times 10 equals 30. Okay, let's try B. 5/8 of the prizes at the giant spin were dolls. If there were 64 prizes, okay, so it says 5/8 of the prizes. We know there were 64 prizes, so we know that's being multiplied times 64. And then that will tell us how many of those prizes were actually not, how many were not dolls. Okay, I need to remember that. So let's find out 5/8 were dolls. So remember, we have to go back and find the 3/8 would be the not dolls. So actually let's just use 3/8 right now. We don't have to do 2 steps. 5/8 are dolls. That leaves 3/8 left that are not dolls. So 3/8 times 64. Again, you can just multiply straight across and divide. I'm not going to, because I know that will be quite a big number I'll have to deal with in my head. And I love to do mental math because it's faster whenever I can. I'm going to cross reduce here. 64 divided by 8 is 8. So now there's nothing on the bottom but ones. I don't really need it. It's not going to change anything. I'm left with 3 times 8 is 24. See, if I finish down on the bottom, 24 over 1, which is still just 24. So 24 were not dolls. Okay. $117. Order these numbers from least to greatest. And it says, note, there's more than one approach to solve this problem. Yeah, of course there is. There always is in math. That's what's so great about it. I see some fractions, and I see some decimals, and I see some whole numbers. It's totally up to you. You can do whatever seems more sensible for your brain, but I think in this situation it might be easy just to turn them all into decimals. You either want to have them all fractions or all decimals, because then it's just super easy to compare when they are like things. So 1/2 can be written like this, 5/10, right? And I'm going to just rewrite the whole list, and then we'll put them in order. 5/3, let's see what that really means. 5/3 is the same thing as 3 goes into 5 one time, and out of 3 there's 2 left over. Well, 2/3, if you were to divide 2 by 3, would end up being decimal 6666666, whatever. So this would be 1 and 66 and it keeps going, but that's all I need. So actually, I can even use this 6 to round this 6 up to a 7. So, and then we have a 2, we have a 0, we've got 4/10, we have a -2, And then we have 5/8. If you divide 5 by 8, 6 times 8 is 48. Subtract 2, bring down the 0. Goes in twice. Bring down one more 0. Okay, so decimal 625. Let's let this 5 round that 2 up to a 3. Okay, now we are ordering least to greatest. So our negative number, obviously, is our smallest. Actually, I'm just going to cross it out like this. And let's see, no more negatives. So 0 would be our next one. Now we can start into the positive things. So we've either got decimal 5, decimal 4, or decimal 6. So decimal 4, and then decimal 5, and then decimal 6, 3, cross them out. We've got 1, 1, and 2, so let's do 1.1, 1.7, and then R2. See how easy it is to do once you get them all in the same form? $118. Find each sum. Okay, it's just practicing adding fractions with unlike denominators. Okay, so let's try what I showed you. Get your denominators, start with the larger number, and start listing multiples, and ask yourself each time, is 3 a factor of that number, or does 3 divide into it? It means the same thing. So 5, 3 is not a factor of 5, 10, 3 is not a factor of 10, 15. Look, there it is. That's the very first one that they both have in common. So it's going to be a 15. And take note, we also could have gotten there by saying 5 times 3. That often works, you guys, but be careful because sometimes there really is a smaller number than that. But as you get more used to this, or as you know your multiplication facts so well, you will know this without even having to think about it, I promise. So here's our giant ones. Get them all set up. I feel like I don't have to talk you through every step anymore because they're actually having you practice this quite a bit and you're probably getting really used to it. Okay, and also if I were you, like if you felt like you needed to really practice this, I would pause the video sometimes and really just try by myself first. I think it would be really good for you to know what you can do on your own, and then watch the video to check your answers. Or if you get stuck, then press play and, hopefully my explanation can help you. Okay, a 2 and a 7. I'm going to go ahead and say, 2 times 7 is 14. And that actually is the lowest common denominator. So now I'm not even going to write the giant one here. I'm just going to say 2 times what is 14? Well, it's 7. So I know I need to say 1 times 7 gives me this 7. 7 times what is 14? 2. So 5 times 2 is 10. So now you probably can picture the giant one without even having to write it. So that would be 17/14. That's improper, so think 14 goes into 17 one whole time and out of 14, and then you just subtract it, 17 minus 14. 3 is left over. Okay, 1/6 and 2/8. Okay, let's see, we've got a 6 and an 8. Does a 6 go into an 8? No. Does a 6 go into 16? No. Does a 6 go into 24? Yes, there it is. That's our least common denominator. 8 times what is 24? 3. So 2 times 3 is 6. 6 times what is 24? 4. So 1 times 4 is 4. Then you just add them up, and that's 10/24. they both happen to be even, that tells me immediately that I can reduce it, because if they're both even, you could always divide them both by a 2. So 10 divided by 2 is 5, and 24 divided by 2 is 12. There you go. That's the lowest we can go. Okay. That finishes up another section, guys. Hopefully this is helpful, and I'll see you next time.